Oh no, the struggle. So this is take number 2. I just sat down and did this video before, and my microphone did not record any of it. So the struggle. Anyway, welcome you guys to the second example for prediction intervals and the last tutorial video, fingers crossed, of this year. If I have to make another one of these, goodness gracious. Anyway, a little frustrated, y'all. Let's get started. Here we go. So today, for the prediction interval example, what I thought we would do is do something a little bit more interesting than just like heights and shoe sizes. What I thought we would do is try to predict the future. So what I decided to do was let's try to predict what the next Olympics winning 100-meter dash time would be. The way we're going to do that is we're going to gather all of the winning times for the previous Olympics, and we're going to put that into a spreadsheet, and we're going to see if we can predict like I said, the future. Now, starting back in 1896, I looked at the winning times again for each of these years, and then I put those into a spreadsheet, right? So starting at 1896 all the way through that last Olympics of 2016 with the winning time of 9.81 seconds. Now the next Olympics is it's supposed to be this year in Tokyo. It's going to be next year now because they moved it due to the coronavirus. So we're going to be trying to predict what the winning time is going to be in 2021. So before we even get started, let's just check to see if there is a correlation here, because that would be a waste of time if there wasn't. And the prediction wouldn't be very good if, again, there was no good correlation. So let's go ahead and take a look. As you can see, that there clearly looks to be a pretty decent correlation. Let's see what the best fit line would look like. Going into series, hitting trend line, going to label the equation. There we go. So yeah, I mean, I would say that the points are all pretty snuggled in pretty nicely to that best fit line. But just to make sure, let's run the correlation coefficient just to see what the actual correlation coefficient is. And again, I'm expecting this to be a pretty good number just because of the visual of that scatter plot. So yeah, almost negative 0.9. So this is a very strong negative correlation that as the years go on, the winning time is going down. Now, of course, it's not dramatically going down, but in the world of sprints, right, just even the smallest margins can be a big victory, right? So we're definitely going down in time. Now, what I'm trying to say is this is just a snapshot in time, right? I can't make huge predictions back to, like, for instance, the year 3000, right? There might be a limit to this, right? But in terms of just this like window, it definitely seems that we are trending downward. So when you're making predictions, you can either make a prediction within the window. So for instance, there was a gap here due to World War II. We might have predicted what the winning time would have been if there was an Olympics held there. You can also go a little bit on the outskirts, right? So for instance, like what we're doing is just like off to the right here. But you just don't want to do anything like, let's predict what's going to happen in 2050. Right? That's a little too far out of the window, and we're not sure if that trend will continue that far out into the future. So just a little word of the wise, you can't predict too far into the future. But on the edges, like 2021, definitely I think that this equation will hold up. So let us get started with this problem. Oops, don't want to delete that just yet. But I will get rid of that. We don't need the correlation coefficient anymore. So here we go. Second example that we're going to look at is the year versus the Olympic winning 100-meter dash time. We're going to go through the exact same steps as last time, no different, and hopefully the second time through will make things a little bit more clear for those of you guys who struggled through the first one. Example number 2. So we're going to construct a 90% prediction interval for the winning 100-meter dash time for the 2021 Olympic Games. And then it says, what can you conclude? Again, pretty common way of asking this type of a question. Let's get started with part 1. So part 1 is going to get the degree of freedom, and we're going to do that by getting the sample size minus 2. So let's go back to our spreadsheet, see how many years we collected or how many pairs we have. It's down to like the 29th row, but again, I used the top row, so it's really one less than 29. So it'd be 28 is our sample size. So let's go ahead and do that. 28 minus 2, that would be 26. So there's our degree of freedom. We'll need that when we do our t-score. All right, step 2. the best fit line. So we're going to be plugging in XO again represents the year that, or the X value that you're trying to predict for. So we're predicting for the X value or the year of 2021. So we're going to plug that into our equation. So yeah, we'll be using the negative 0.0126 times the 2021 plus 35. We'll be using that best fit line to go ahead and do that. Again, I would recommend doing your calculations in Desmos. That will save you a lot of time. So let's go ahead and calculate that real quick. So the negative 0.0126 times 2021 plus 35, I am getting 9.54 as the predict value. So again, this is just a prediction, not a strong prediction. Like I wouldn't put my money that it's going to be exactly 9.54 the winning time. We're going to need the margin of error to get a little bit better, more accurate prediction here, and we'll do that next. But I will say 9.54 is technically under the current world record, so if that says anything, maybe we might get a winning world record on our next Olympics. But anyway, let's continue. Step 3, T-table time. So I'm going to go over to the T-table now. I'm going to go to the 90 percentile, and or sorry, not 90 percentile, but the 90 confidence level, and we're going to go up to the 26th line because that's our degree of freedom, and we have 1.706 as our T-score. So we're going to put that as step 3 all done. So again, step 1 through 3 shouldn't be too bad. It's step 4 through step 4 and 5 that tend to be a little bit more daunting. So let's take a look at them. Step 4 again, we are going to be summing the difference between the y and the predicted y values and squaring them. So again, what this is again, each of those winning times, we're going to subtract where the best fit line is for each of those years. And you'll notice again when you're looking at this that some of these actual winning times is a little bit further away than the best fit line, and some of them are a little bit closer, right? So that's pretty much what you're doing in the standard error is you're looking at the differences between and getting that average distance to the points and the best fit line. So the first thing you're going to want to do is get the predicted, aka the best fit line location for each of these years. So I'm going to call this one y hat. And what you're going to do to get those is you're going to do the best fit line equation and plug in each of the years into it. So let's go negative 0.0126 times this time 1896 plus 35. Make sure again you're not typing in 1896, you're clicking, because again this will save you some time in a moment. Again, just to make sure you understand, 11.11 is the location at that particular year. You'll notice that it's below the winning time of 12. Okay, so that's again what the y hats are doing, is the best fit line location. So I'm going to drag this equation down and get all of the other locations for each of the other years. Next thing I'm going to do is delete this because we really don't need it much anymore. It's just kind of taking up space. Next thing I'm going to do is the y minus y hat. This is what the actual standard error equation is asking us to do, and get the sum of that. So the first thing we're going to do is we're going to replicate that. We're going to take each y value, or the actual winning time, subtract it from the best fit line location, the y hat, and then we're going to square them. The reason again we square these is to turn these values positive. We can't have negative and positives because when we go to add those up, you end up getting those to cancel out, just like the standard deviation formula we talked about earlier this year. So anyway, so I got those all done, drag that equation down, and now I'm going to find the sum of this row. So I'm going to, whoops, went a little bit too far there. Going to highlight that whole entire column and then hit enter. So the sum of the difference of squares is 1.405. So that's what's going to go into the top part of this equation, and we are going to divide that by the 28 minus 2. Again, can't stress it enough, using Desmos for these problems would be a lot better. It's going to save you a lot of time and heartache, and you won't have to worry too much about order of operations. So 1.405, we're going to divide that by 28 minus 2, and that would give us, again, automatically the answer. And you don't, again, as long as you type it in the way it looks in your equation, the order of operations will take care of itself. So this standard error is 0.232. Okay, step 4 completed. Let's go into the mother load, step 5. So we got most of the stuff that goes into this before we plug and chug, but there's a few other things that we still have to find. Quick reminder, the XO again just is the year that you're predicting for, or the X value that you're predicting for. So in this case, we're gonna fill this in with 2021. Anywhere you see ends, we'll put 28. We just got this in the previous couple steps. The only thing what we need to get is the mean of X, which we can do on the spreadsheet. We need the sum of the X squareds, which again, we'll do on the spreadsheet. And then we also need the sum of the X's. Again, we'll do that on the spreadsheet. So let's go back to the spreadsheet real quick. Let's go to getting the sum of this X column first. So we'll go sum. We're going to highlight all of the X values, aka all of the years through 2016. Hit enter. So that number will go in the sum of X part of the formula. We also need the average, aka the mean of the X's. So we're going to highlight that all the way down to 2016. Again, don't include that other number because that's the sum. You just want to make sure you only highlight the X's there. And the mean would be 1958.43. So we'll put that in for the mean. And then last but not least, we need the sum of X squareds, okay? Which is not this number squared, it's each of these values squared and then summed up. So we need to do a little bit more work to get that. So I'm going to go X squared just to remind me what this column represents. And what I'm going to do is I'm going to have the spreadsheet do an equation where I go equals, click on that first X value, and then we square it so that the spreadsheet squares these numbers. And we drag this equation down to the 29th row to make sure that we don't square too much. It will be squaring each of these years or X values as we go on down. So obviously these numbers pretty big. We're going to sum this real quick because that is what we need to do to plug into the equation. Again, it's the sum of the X squareds. And we get 107,429,904. Big number, but good news, again, we're going to have a calculator take care of this. We don't have to do this by hand. Thank goodness. Anyway, so let's plug these into our equation here and make sure everything's in the correct spot. So t-score 1.706, standard error 0.232. The ends, again, have been replaced with 28s. The XO, again, is the year that we're predicting for, the X value that we're predicting for 2021. The mean, again, we got is 1958.43. The sum of the X squareds is that big 100,000,001 number. And then the sum of the X's is just that 54,000 number that we got from summing the X column up. So now this is going to be thrown into the Desmos calculator, and I urge you to do that right now just to make sure that you're entering everything correctly, and then check to see if you got the same answer as me. All right, so here goes the answer. The answer ends up being 0.42 for the margin of error if you enter that correctly. Okay, so finishing steps here. We're going to, at this point, take our prediction that we had from step 2, and we're going to add and subtract the margin of error to it, and that will become our interval. Here goes that work. So 9.54 is our prediction. We're going to add and subtract 0.42 to it to get those end caps, 9.12 all the way to 9.96. And that would be what is known as the prediction interval. So conclusion, there's a 90% chance. Again, that confidence level is just the percent chance that this will be correct. Very good chance, by the way, that the winning 100-meter dash time at the 2021 Olympics, fingers crossed if it actually does happen, will be between 9.12 seconds all the way to 9.96 seconds. And that is it. So I think this is kind of neat. Mainly just because of the fact that, again, these Olympics haven't happened yet, and we have a pretty accurate way of predicting what the winning time will be. Now, again, yes, the range is a little bit big, and 9.12 is much different than 9.96 in the world of sprinting, But if you can see how this might be utilized, being able to predict different numerical values in the future, you could see how, for instance, investment firms might use this to predict what happens next to stocks in the stock market, right? There's a lot of valuable things that statistics can do to predicting future events. And this is just the tip of the iceberg, obviously a more introductory analysis way of doing it. In the more upper level stats classes, you'll see a little bit more complicated stuff and a lot more computer stuff and modeling to go ahead and make these kind of predictions. But this is where we're going to end in this stats class. The last assignment will be, again, practicing this a little bit more so you have some exposure to some of these problems. And that will be it. If you need any additional help, there's just 1 or 2 more office hours days. Thursday is the last one from 1 to 2 p.m. Other than that, I hope to see you guys all in person in the fall. You guys, again, thanks a lot for sticking around this online education thing that we've been doing for the last couple of months. For those of you guys who have been trying your hardest, really appreciate that. I'm very proud of you guys. So anyway, talk to you guys later. Have a wonderful day and summer. Bye.